In our next session, we would like to now invite innovators. So we would like to open up again the floor to hear from their journey, how innovation has taken uh, shape and how it has been developed by these great innovators and great engineers. And we would like to highlight some of the things that they have done. So I would like to first hand over to Nayan, who is the director for Element NYN, and who is an award-winning electronics engineer. So he has recently developed an orthopedic support and therapy device, and it was a pleasure to work with him during the development. And he's a great entrepreneur, and he will be now talking about his journey and his great innovation. So Nayan.
So hi, my name is Nayan. I'm the director of Element NYN. I'll explain what this is a little bit later in the presentation, but I've created the first to market electrically operated orthopedic support that provides both hot and cold therapy. So before I go into that, I'll just explain a little bit about myself first. So I studied I studied electronics, physics and business at A-levels. Went on to University of Leicester and studied electric and electronic engineering. I'm all about martial arts, and as a hobby, I've competed a lot, do boxing, jiu-jitsu, competed at international level, so very active, and currently work for Jaguar Land Rover. And the reason why I got that job at Jaguar Land Rover was, excuse me, partly due to my final year project, which I made a self-driving car using internet protocol using TCP. And at the time, I also was investigating something called SLAM, which is simultaneous location and mapping. So if you've seen the new Hoovers that are around now, which are they're basically autonomous, where they're almost like the size of a big puck, and they just go around the whole house, hoover the whole house, and come back to their spot. What they do is they produce a map of your area, so you don't need GPS, and they've got it for gardens now as well to cut your lawns. So I was doing that, and that got me the job working for Jaguar. So I started with Jaguar Land Rover in 2013 as a graduate role within research, and then I moved on to advanced product creation. So in 2015, that's when Land Rover was doing really well. We were selling Evokes. That's when the Evoke came out, one of the most popular cars at the time. And I was lucky enough to work on stuff called like mega projects. So we were looking at certain areas of the car. So it might be in-car entertainment or Tranquil Sanctuary, it's called. So that's the in-car cabin. So we'd look at certain things like the steering wheel. I was working on a see-through trailer, which is out now, where if you've got a trailer, a lot of Range Rovers have. That's why they buy the cars. You're able to see behind the car. It's really good technology. Working on fog mitigation, which I've got patent for the company. We're using polarizers, using polarized light to be able to see further through fog, using time in flight cameras, and I also worked on mirrorless car. I then moved to simulation, because we're working on self-driving cars, and I was telling Omar, I think a couple of days ago, that we need to do, I think the rule is we need to do 100,000 hours of virtual simulation work before a car can even be put on the road. So I was working on part of that. One of my tasks was working with Addison Lee. So we had a project which was really interesting, where we had to go from London Olympia. It was like a shuttle service where we would pick people up, we'd drop them to Heathrow and come back, and it was like a big circular route. And that was all autonomous. That's the stuff I was working on. Very interesting. Most of the work I've did with simulation was government funded projects, so I was able to understand how all of that works. Very interesting, very in depth as well, a lot of paperwork. And now I'm working in diagnostic prediction using deep learning. So we're predicting what errors are going to come up. So that's going to help with the diagnostic side, help with error predictions, trying to find what problems cars are going to have in the future, and also predicting what parts are going to fail, and basically trying to help the customer. And this is saving the company millions upon millions of pounds. So whilst working at Jaguar Land Rover between 2015 and 2018, as I mentioned, I was competing a lot in my spare time, and I dislocated my shoulder whilst competing. So when you dislocate your shoulder, obviously you get a lot of swelling around the area, and that swelling you need to ice. And unfortunately, ice melts really quick. You've only got one iteration before you have to put it back in the freezer. It takes like 5 or 6 hours for it to freeze again. It's very difficult. So I thought, okay, there must be a better way of cooling, because I needed to go work as well, and you can't drive with a dislocated shoulder. So I thought there must be a way of coming up with a solution. So that's what I started working on, and I got in touch with University of Leicester. So as Plato says, necessity is the mother of all inventions. So I created a device that produces hot cold therapy. Basically goes down to 3 degrees, 2 degrees, maybe even less if I wanted to. And I contacted the University of Leicester because I saw that they had an innovation centre and business startup. Contacted Rajinder, who's obviously part of this meeting. And with her help, I was able to file a patent. We also entered some competitions, and I won first place. And the person I'm with there is Sam Woodrow from Dragon's Den. He's a creator of Yo Sushi. So this is where my journey started. I created it for humans, but the problem with working with humans is the aesthetic side is very important. It has to look a certain way, certain shape, size. So there was a lot of work that needed to be done, a huge amount of work. And the main problem was funding. I had to pay close to over £100,000. Sorry, over £100,000 for clinical trials, and we just don't have that kind of money. Obviously, I could have got funding and investors. I did speak to a few investors, but the percentage that they're asking for was ridiculous. It was a lot. So instead, I just diversified. I went to a different direction. So instead, I started looking at horses. Horses need the same technology. So after doing some research, I found that horses on the lower part of their leg, as you can see the image on the right, it's called the superficial digital flexor tendon and the deep digital flexor tendon. These tendons, when horses go to exercise and when they're out, they get knocks quite a lot, and much like humans, they get a lot of swelling there, and this swelling causes a lot of problems. So what you need to do is cool the horse's leg, much like humans. So my technology works for them as well, and as it says here at the bottom, create the current methods. Currently, what they do to cool the horse's leg is they stand the horse in water with ice, which reduces by 136 kilojoules, hosing the horse's leg. See the problems, and I found quite a few problems with these. So the current method is standing in cold ice water. If you have a horse, it's very difficult to get them to stand still. So one of the good things about the university, they've got a wide range of people. So Lucy, she owns a horse, and me and her were discussing, stuff about horses. I'm not a horsey person, so it was very good getting the information from her and Helen. And so yeah, so standing a horse in water is very difficult, especially if you're going to events, producing ice and then getting a bucket, and it's very difficult. Hosing a horse's leg is another option. So you stand there hosing a horse's leg down, but that requires manpower. You're standing 20 minutes per leg. That's 40 minutes per horse, and sometimes and a lot of these horse owners have over 100 horses on their lot. So imagine trying to do that. It's a long time. Ice packs, they take a long time to cool, as I mentioned earlier. You need a massive freezer if you've got a few, if you're going to keep replacing them. Clay doesn't, basically it's placebo. It only reduces it by 8 kilojoules. So whereas my product is going to be between 75 and 90 kilojoules. So my product here, it looks like what is on the left, and I'm still in the development stage, but the main thing is that it works. I've got a short little video just to explain what it does. Okay. So currently here, this is my initial thought. This is how it started. I went to doing some market research. I went and spoke to about I think about 8 different horse lots where they have between 100 and 120, 150 horses per stable. And when I went and spoke to them, this was my initial idea, where you can attach the device to a horse's leg. You can have a Bluetooth device. You can go back into the room, and it can do the therapy whilst you're away, or if you're driving a horse one place to another. After speaking to them, one thing I noticed was they don't care about any of this digital stuff where you have Bluetooth and AI and all these other things I was thinking about for how to make it better. All they care about is functionality and the product doing what it should. So as the video shows, this is pretty much exactly how it works, where you can reduce the temperature within the space of 30 to 40 seconds. So the equine market, doing some studies, we found that it's worth 218 billion worldwide. My product has no chemicals. The UK have over 374,000 horses, horse owners, sorry. So there's way more horses in the UK. The UK alone has 4.7 billion pounds that they spend on the equine market. What I'm doing is a known therapy, but I've just modernized it, and I'm first to market in what I'm doing. Some of the research, some of these components people are buying, the price ranges between £70 all the way to £10,000. As these initial products here, you can see they're really big and very expensive, and you need to, whereas mine is something that you can just stick on to the horse's leg. This is some of the things that you have to carry about everywhere, so it's very cumbersome. Where I currently am, so whilst working with the university, I designed this myself, and with the help of Omar and the other team, we got to this stage. So this is a working prototype, and this is the next iteration, part of what Howard was mentioning earlier, with the whole circle. So we designed this, we knew what errors that we made, and we've now in developments of creating this as a final prototype. So we're aiming to reduce the weight. We can get to 3 degrees within and hold it for 12 minutes. We're aiming to do 3 cycles of that, and we're refining the battery. Some of the challenges that we faced was thermal efficiency, trying to get the best contact area on the horse's leg. The components that we're using currently, I am using things off the shelf, and it's a balance of, do we have custom items made, or is it okay to continue with off the shelf? There's some of the software that we're doing as well. That's quite a big challenge, and because it's a completely new market for me. So I'm new to this whole market, so understanding what these horse people want. Things like, can we have one size fits all, or does it have to be custom to each horse? So this is how the university helped, and it's very, very beneficial, and it's probably accelerated my work tenfold. So things like thermal efficiency, the problems that I had, the university were able to provide thermal analysis work for me, which, like I said, helped immensely. Offered 3D printing. So as you can see here, this is the 3D printing I did at the university. Material knowledge. So Omar, obviously very good with the materials. He was able to help and suggest which is the best solution, and manufacturing solutions as well. So Howard was also very helpful with some of the software that we were doing, coming up with suggestions and prototyping. For the market research, Helen was able to produce some documents for us. I think it's about 50 pages of looking at clinical papers, and luckily this supported the work that I was doing. and also was able to provide this equine survey. So that was very beneficial to the work I was doing. And the future work for us is I'll need to hire a equine specialist. We'll be visiting trade shows in Ireland, UK, and America. That's some of the things that we'll be looking into. We need an online presence, looking at distributors and agents. We're thinking about increasing the product range and tailoring our device. So we can have, for example, our product, we could have it so that it could meet different horses, different horses. So we can be custom made per horse rather than just a generic device. So I've tried to keep this very high level, so it's hopefully very easy to understand what we're doing. And yeah, I wanted to try and keep it within the time frame. So I hope that makes sense. And obviously, if you've got any questions, more than happy to answer anything. So I hope that's okay, Omar.
Yeah, Nayan, that was great. Thank you very much for describing your journey, your product, and your innovation. To be honest, that was just a great overview. So I just want to open up to the questions quickly before we move on to our next innovator. And Nayan, I think there is one question. So if you can turn off your yeah, thank you. So there is one question. So what CAD system were you using? I believe that's SolidWorks.
Yes, I was using SolidWorks. So
yeah,
the thing was I had to learn a lot of it myself. There's a lot of resources online. So any advice to any budding entrepreneurs is try and learn as much as you can yourself. It saves a lot of money.
Yeah, and there is another question from Tony. So what is the horse product company name and the contact details? I had some questions, but have been called away soon. So.
Yes, the company's called Element NYN, and I'll post my details if anyone's got more questions. Perfect.
Thank you very much, Nayan. Thank you. So considering the time, I think you'll also stay for the upcoming networking sessions. Considering the time, I would like to move to our next innovator, next excellent product, which will be presented by Piyal Samara-Ratna from Space Research Center of University of Leicester. So he will be talking about the novel delivery apparatus for central venous catheter that he developed together with the with some clinicians in the University of Leicester.
Well, thanks so much for inviting me, and yes, thank you very much for your time, everyone. So my name is Piyal, Meteor Principal Engineer. I lead a team of engineers in terms of technology development. Our primary goal is to deliver spaceflight instrumentation. Been lucky enough to work here for 15 years, delivering a variety of engineering solutions for deep space missions, planetary rovers, Earth observation instruments. And really what ties all of those things together is the fact that what we are doing has never been done before. And there's always this risk that there's a very good reason why it hasn't been done before, because it's incredibly challenging. And that means that we're really good at solving problems and learning about things. Because a lot of these technologies are things that we don't necessarily have expertise on, and we need to build up the expertise quickly. And we've been incredibly successful having an instrument in space for the last 60 years. And what we've done is we've been able to successfully demonstrate that same approach to delivering near impossible solutions to space can be applied to other sectors. So what I wanted to talk to you about was one of the programs that we've undertaken with a clinician who was at the Hospital of Leicester's NHS Trust, and this was the BCADS delivery apparatus. So this was a really exciting, interesting project for us to basically optimize how clinicians gain access to the venous system of the human body in order to administer treatments. And this is a real bread and butter type procedure that's performed almost every day in the NHS. 200,000 procedures are done annually, 5 million in the US. And what it is that the first port of doing some form of major surgery or treatment is to gain access to the venous system so that you can apply drugs or any kind of treatments there. And this process is quite complicated and fraught with risk. You're essentially taking a needle, two vessels, maybe in the neck or in the leg or the collarbone area, and you're then trying to install a catheter which will will essentially allow you to administer your treatments. And when you're doing this, you are using a sharp needle in a region where, as you can imagine, on your neck, there's a lot of important vessels there, and the risk of causing severe trauma is very high. And this, even though this procedure is done regularly and the techniques have been established for many decades, the complication rates are still very high, at least above 15%. And the people who regulate the industry in the UK, NICE, they've recognised this issue, and they've suggested and recommended the use of ultrasound probes during the procedure. So you hold an ultrasound probe against the area where you're gaining access with your needle, and you can see beneath the surface, and you can tell whether you're going to cause trauma or not. And that sounds like a very clear and sensible thing to do. But the challenge is that the procedure itself has never ever been optimized for use with an ultrasound probe. Essentially, you need a third hand in this procedure. You're meant to be looking at the patient's neck, but instead you're looking at a screen. Further compounded by you having to use a plethora of complicated tools and equipment, and these are all optimized for using in a two-handed approach arrangement. Now, it wasn't me who discovered these issues and more importantly found potential solutions to this problem. It was Dr. Atul Gore. He's a consultant anaesthetist at the University Hospitals Trust, and Atul's one of these special people who can find room for improvement in anything. And he correctly acknowledged that there was this problem here. But most importantly, what he was able to do was identify a potential solution there, how you could add this equivalent of a third hand into this process so that you could do your procedure safely and also have the ultrasound probe held in place. He worked with the trust, and they actually patented an idea. This is some extracts from the patent. And what it was based upon was this novel idea of having an insert into the needle that when you needed to, you could use it in a single-handed process. You could essentially blunt the needle so that it was safe and continue on your procedure. And you could effectively take a two-handed procedure to a one-handed procedure, and therefore have another hand available so that you can use the ultrasound probe in its best possible way to ensure safe installation of the devices that you needed. Now, Atul is a great idea, but fundamentally there were technical issues in terms of how could this actually be achieved as a physical product. In the patent, there were clear areas where there were gaps. There was this hidden curtain about where some of the engineering had to occur, and that's where he came to us and said, what can we do to try and progress this innovation. So we've done a lot of these kind of projects before, and for me, and I think to condense down what others have said, it really does come down to requirements, understanding exactly what you need to do, and the risks associated with achieving those goals and objectives. And we've taken this same approach to any type of program that we are associated with. In terms of requirements, we are very careful to, at this stage, from the very start of a program, to start defining requirements. Exactly what are we hoping to achieve, both in technical, business, also being incredibly clear about what we don't know. We need to achieve something, but we don't exactly know what exact metric of success we need to achieve, and therefore we can build a program to address that. And these requirements lists, these are the backbone of our projects. These are living documents. They get updated, they get reviewed, they get checked all the time to ensure that we have across the board technical compliance, business compliance, project compliance, against everything that we're trying to achieve with the people we're working with. And when we looked at risks, there was obvious one about, can we build this? We have a lot of interesting ideas, but we're talking about sketches, but can we actually take that forward and actually build something and see that it works? So we're able to produce some very simple concepts. From my point of view, I'm a big fan of PowerPoint, doing sketches in PowerPoint. We do our documentation in PowerPoint. It's important for us, as Howard has said, that we do documentation, and we make sure our documentation is useful for us. And that's the best way of ensuring that the documentation is created. But lightweight methods like PowerPoint are great ways of having digital logbooks of what we do. So we did some concept designs, different methods of doing things. We then put together cartoons of how we thought the device would be working. These are all things to make sure that we were properly interpreting Atol's requirements into a proper feasible solution. We then produced our first non-functional prototype. So this was a very quick, rapid start build of a non-functional device, but was something you could hold and go through the process quite simply. And that really gave us confidence that we had something that could, with optimization, be taken to a single-handed operation, reducing the number of operations from 13 to 8. We could reduce the number of components in the kit used by the clinicians. This obviously aided the procedure being simpler, but also had a cost benefit, which was incredibly important if this was to be commercialized. And from there, we then had confidence to start doing CAD modeling. At the university, we have a really high fidelity suite of design, analysis, manufacturing tools. We use exactly the same engineering environment that SpaceX, Elon Musk products use, Formula One teams use, and we use that for any applications. We are fully commercially licensed. And we came up with concepts like this that effectively allowed us to take the product forward in terms of something that was actually manufacturable. Enabled us to build our first working functional prototype. So this was all done in-house at the university. It's worth saying that we now have an increasing number of technologies and tools that can allow us to do this even quicker nowadays. But this was a CNC manufactured, primarily CNC manufactured assembly. It met all our ergonomic requirements. It functioned essentially how we wanted it to do. The only trade-off that we had to do on this one was that it wasn't optimized for mass manufacturing, and that was something that we were acutely aware of. And you know, so we could test with this, but in terms of delivering on a commercial level, you know, this had to be addressed in a separate way. So, you know, to make a commercial device using mass production tooling, incredibly expensive, at least £10,000 plus for tooling. So we actually made a non-functional prototype which actually demonstrated the ability to mass produce this device. This was incredibly important in terms of the business model, because what we were proposing to do was for this device to enter an industry where our competitors were incredibly well established. You know, established for many decades with many different competitors trying to sell the product. Economies of scale were fully flourished. And what that meant was that any competitor entering the market had to be at a rock bottom price. So this non-functional prototype allowed us to demonstrate the ability to reduce the number of components, and also allowed us to show that we could rapidly assemble this device for mass production. Then it was a case of, can we prove that it works? And for this, we were able to build a number of test models and utilize some more high fidelity test models and generate videos, promotional videos and things like this. And it's worth stopping here to sort of say that a lot of this development work was really only feasible because of student effort. We actually employed 2 students during this program to work on this as part of their student work. And it was really essential because some of this work, it is resource intensive, we are busy. And students are incredibly helpful in terms of doing this. You know, the videos at the bottom there were taken by students of the project. The test rigs were set up by students, and that's great. And what that allowed us to do was to develop a whole range of results, you know, high integrity results that actually demonstrated that our product was working. We're able to get X-ray, ultrasound information, which shows the device's operation, and all of this became like a data pack of different information, which all gave confidence that we were going in the right direction with this particular product. I think the other thing that was very important was that we actually ran a clinician trial as well. I think it's very important to get independent feedback on your product. Sometimes you're too close to your own designs. You know, it's difficult to take criticism. And you have to ensure that you do get that independent view on your devices, on your designs, and trying to see if they can spot flaws. So we organised a clinician trial event. This was all done as part of a CPD event, so it allowed clinicians to actually do this part of their training. And in this, we set them up with various models for them to test the device, and with questionnaires, we were able to get feedback. And it was a really interesting day, really rewarding. It was at one end, it was great when a clinician completed the procedure, looked up at us and said, I really think you got something here, and that was fantastic. On the other end of the scale, it's amazing when you work on something, you hand it to someone else and they use it in a way that you just didn't expect, and the first thing that happens, it breaks. And that was a really useful learning exercise for us, because it identified flaws and areas where we could refine. So it was incredibly important that we were able to do this and get independent feedback, and then use that to strengthen the design and the overall proposal. The final one was can we commercialize it? We had this data pack of information that really hung together to form this complete confirmation that we had something that could potentially go somewhere. So again, the university was being really helpful in terms of together with the trust in terms of developing the business model and marketing. The university team produced a brochure advertising it. The university has great connections to various networking events would link different people together and allow you to present your solutions at different places. And we attended those. We had lots of discussions. We were able to put together a very clear business case based around some clear benefits for the product, and we entered into a number of discussion with investors, the kind of Dragon Den type event activities. And the end result of that was that we were able to secure a licensing deal with the company. And it was very, it was a long process, but it was something incredibly rewarding, and it takes a lot of hard work, but it's great to see when we're able to secure a deal like this. Now, unfortunately, the pandemic has hit. We haven't been able to make the progress that we wanted in the last year and a bit to be able to take it forward. But we are working with the company. We're looking the wider university in terms of running clinical trials as well. There is, particularly in the medical sector, there's such a deep level of expertise that can be utilised to take a product from that initial sketch all the way through to a commercial device that can be used. So this is all things that we're hoping that will start to gather momentum again once we hopefully return to normal working conditions. I think, just in summary, I think this is just one of many different cases of us working with people who have great ideas but don't necessarily have the resources to take it forward. And it covers, that expertise covers a broad range of areas, range from product development, business and marketing support. I think it's important to highlight the benefits the student effort can give. I run a team of engineers. There's 7 people in the team. 5 of those members are actually stemmed from intern employment from students. I think it is a resource that can really help accelerate programs if they're used correctly. So I just want to thank you for everyone for their time, and especially thank Dr. Gore and the Hospital Trust for supporting us and getting us involved in this really exciting project. And I'm happy to take any questions. Thank you.
Thank you very much, Piyal.